Thank you very much for coming. It's quick introductions. My name is Shivan Bindal. I'm a product manager here at RightScale. Can everybody hear me okay in the back? Everybody good? Yeah? Good. All right. My name is Shivan Bindal. I'm a product manager here at RightScale, and to my left is Raphael. Simone, he is a senior software or senior systems architect. Sometimes I forget. And both of us actually dedicate a lot of our time towards working on Windows applications in RightScale to enable a lot of the functionality that we'll be talking about today. I wanted to cover a number of things in this talk today, and really we'll start out by talking about clouds and what our options are, what the challenges are with going to clouds, and then also cover a lot of the things that RightScale does to make your life a little bit easier as it comes to the Microsoft stack in cloud. Here on this slide we're really talking about how do you actually choose your cloud? Before you even decide, whether you want to go infrastructure as a service or PaaS, you need to understand what your needs really are. In this slide, we sort of capture some of the pros and cons of going with either solution. I don't want to dwell too much on either. It really comes down to what you need. So in terms of challenges in the cloud, there are quite a few. I think those of you who have tried to launch Windows applications in the cloud, you may have encountered some of these. To start off with, as we look at all the various clouds that are out there, images in particular can be problematic. For example, if you look at Amazon and all of the regions, each AMI in East versus West versus Asia Pacific versus UK, you might find various things in the contents of those images that are just not standard. So you don't know necessarily what to expect as you look in these AMIs, and when you go to launch your applications, it may not be a seamless process. In terms of software license management, there is really none. Aside from what you pay for your usage on the server itself, you don't really have any built-in software license management for other applications you want to install. And in terms of best practices, this goes down to design, security vulnerabilities, firewalls not being enabled by default, ports being left open, the configuration of where your data resides as you launch these servers in the AMIs. A lot of best practices are not followed.
All right. So in terms of overcoming these challenges, what do people normally do? Well, they do exactly what the IT admins of the olden days did, which is burn master disks, put everything in the image, bake everything in, custom configure their application down to even pushing credentials into the images themselves and leveraging those in their applications as they launch applications in the cloud. What this creates, though, is very long development iterations as we look at how do you change these credentials, change any of your configurations in your applications and things like that. You end up having to rebuild your images from the ground up, really. And so, from there you really get into, well, how does this become a sustainable process? The trust relationships are baked into my images. There's no automated orchestration. How do I really get this going? How do I really do this for real in a production environment so that I can scale? Well, so what RightScale has done here is we've actually built our own Right images, and what we treat Right images as if you can see at the bottom here, is a secure, reusable base from which you create automated configuration and orchestration. A key component in the RightScale approach
to to launching Windows applications or .NET applications in the cloud is starting with an image, and we treat these images as basic. These are basically what you can reuse. They're the reusable objects. They contain a variety of different things. Let's see, does this have a pointer on here? Yes, it does. They contain RightLink, which is basically our agent. It's what enables us to talk to the RightScale platform and perform certain operations. It also bundles PowerShell 2.0, which leverages a lot of the functionality you have in RightScripts. We'll cover a little bit more of this in detail in a moment. .NET Framework 3.5 and 4.0, some of the standard technologies you'll be using in your .NET applications. Critical Windows updates. We actually do try and solve, at least to an extent, patch management issues in the cloud. We start by every time we release a Right image, to the point in time we actually apply critical updates for you. And every time we roll new Right images, we also update the critical patches as well for you. Application service packs, again, same thing. We want to make sure that the systems you're using are up to date, patched, and appropriate for your use. And in particular with Windows Server 2003, you actually need the install media to custom configure any of these images anyway. So instead of having to attach an EBS volume with the install media on it, we actually just go ahead and put the install media on the image for you. So as we look at images and we start to build up the stack and really identify what RightScale brings to the table when it comes to a Windows Server template, we then come to a multi-cloud image. And what a multi-cloud image is it's actually exactly that. It's a construct within RightScale that enables RightScale to say to you, hey, choose your cloud, tell us what you want to do, and we'll go ahead and pick the appropriate AMI or whatever base image that's available in that cloud. So if you come to RightScale and say, hey, I just want to launch a server with Windows 2008 Server, we'll say, great, tell us which cloud, whether it's Amazon East or whether it's Rackspace. We'll go ahead and know that we will either use the Rackspace image or the AWS US East AMI and launch that server for you. And that all happens because of the construct of a multi-cloud image. On top of that multi-cloud image, we have what is basically the server template. So here we're really trying to identify the actual stack. And down here at the bottom, we have this base configuration, which is the virtual operating system of the machine itself. It consists of write images, and these write images as a collection form the multi-cloud image as we just talked about. Slightly above that, as we look at all the various configurations that are possible and the various clouds that we support, we've got storage and networking options. And to an end user, do you really care whether you're using, a specific type of networking model or a specific type of storage model? No, you just really want it to work and work in the same way across all these clouds. And so what we allow you to do is create a standard configuration from which RightScale will configure that server as best suited to each of those cloud types. And then from there, as we go up, this is where we really get into the good stuff, which is your application, getting to the guts of what you really care about as an application developer, system administrator who wants to get the application in the cloud. So we start with SQL Server, any application libraries, and the actual code base itself that you guys are launching. So a key point here that I want to make clear is that server templates are modular, portable, and reproducible. And we'll keep hitting those points on as we go forward. Just a quick comparison. We talked about baked images on the left-hand side as you're looking at the screen, and server templates on the right. The machine images are big, opaque, complex to reproduce. They're static. It's very challenging to iterate on, and really they represent the old ways of having to burn these master golden images with everything baked into them. They create a very slow workflow, and they're not very agile. Then as you look at the modular approach and the reproducible approach of server templates, we have a flexible platform where most of the stuff that you would have to do on a repetitive basis, setting up the image, configuring it to best practices, setting up your storage, setting up your networking, is done for you out of the box. And really what you care about then is custom configuring for your specific application. And it really does create then a dev-like workflow with dynamic configuration. And we'll actually get to some of the server templates that we have to showcase some of this functionality and this value. So as we look at what server templates really are, let's dig a little bit deeper. We start out, as I said before, with a multi-cloud image, which defines the base software that's on all of your servers. And from there, you start with your flexibility or your configuration. And we have a few different ways that you can do that. All of them are based through RightScripts. And as some of the server templates that you'll see later as Raphael does the demo, you'll see what these scripts can actually contain. But there's basically three different types or three classifications of RightScripts. There's boot scripts, operational scripts, and decommission scripts. And the name says it all. A boot script comes up as the server is launching, when it's in a state that it can actually perform configuration options. Before the server is presented to you as a user in a usable form, we go ahead and perform certain operations that are defined within these RightScripts. Operational RightScripts are exactly that. Any one-time operation or any immediate operation you may need to perform in maintenance modes or otherwise in real time on these servers as they're running. And then decommission, again, remember if we treat these instances, these servers, as disposable objects in the cloud, you can envision them coming down and coming up. But as they come down, you do need to take some activity or take some action to ensure that you're retaining your data in a sane way and what have you. So we have decommission scripts as well to bring your application down gracefully as well. Another very key point, as we talked earlier, server templates really enable a dev-like workflow. They're really, for DevOps almost. And so the nice thing is that we do allow you to version your server templates so that, even though they may be changing, as your needs evolve and you enhance your own server templates or the server templates that you use from RightScale, you can go back to a point in time to a specific version and reproduce exactly the exact same server that you have running. And then other nice thing is that these server templates are shareable. I mean, just like what we do and we provide these server templates to you in our multi-cloud marketplace, similarly you as a user can publish your own server templates, whether it be privately to other users within your organization or publicly to our to the larger RightScale user community. So, a question we often get is, how does this really all work, right? We've got these servers running in the cloud. RightScale runs in the cloud. Yes, we know it's somewhere in the cloud, and it's a software as a service. But how does the communication happen? How does all of this orchestration happen? How do we actually configure the server? Well, as I said before, all of our write images contain RightLink, and RightLink is the RightScale agent that basically, on behalf of RightScale, performs operations on the server. And the way that RightLink communicates with RightScale is through a secure and fault-tolerant protocol. And RightLink basically runs as a service on the Windows platform, on the Windows operating system, with admin rights. And so it can actually run scripts as they're defined within the platform. A few more points about RightLink as I do a quick time check. So first of all, RightLink is an open source agent. If you have any concerns about what we're doing on your servers, please feel free to download the source and look at it. It really speaks to how open we are and how transparent RightScale is trying to be. We don't want you to feel insecure at all about the right images. In terms of what RightLink will actually enable you to do, it receives commands from RightScale. All right? RightScale, the core platform, if we go back one slide and look at this diagram, RightScale tells RightLink what to do on each of the servers. And within this communication protocol, the commands that flow back and forth will enable things like running RightScripts on the local instance, allowing RightLink to discover itself, identify who it is and who other servers within the deployment are, and take actions accordingly. A great example of this is, in an auto-scaling array, a server array, if you have a web application server coming up, and you want it to automatically connect to your database tier that is in the same deployment, RightLink will query tags, query using tags to identify where the database server is and possibly connect directly to that database server automatically. And it can also delegate actions to the RightScale management console or the management platform via an internal API. So performing operations like mounting EBS volumes. Well, traditionally what that would require you to do is to pass your Amazon credentials down to the instance and have the instance then query Amazon to attach, or to create and then attach the EBS volume to your server. Well, that could potentially create some sort of security vulnerability with your credentials on that instance. So instead, RightScale has enabled the RightLink agent to tell the RightScale management platform to, on behalf of the instance, go ahead and communicate that to Amazon so that the right EBS volume can be attached. So in a short summary of what I've just described, we do tend to think of RightLink as a secure agent. In terms of the protocol that it uses to communicate with the RightScale management platform, it is a signed and encrypted AMQP transport. We can discuss that in more detail if you guys have questions later. And again, it is scoped to a deployment. So as I said, in terms of identifying itself and other servers within an environment, it is scoped to a deployment. So it can take certain actions based on that. If some of you are familiar with RightScale, you may have seen a slide similar to this last year at one of our previous user conferences, and to see where are we. And what I'd like to point out here is we've come a long way. We're by no means complete with our Windows offering, but we are making strides and we are dedicated towards addressing the Microsoft market in the cloud. And so to that end, we've actually created some really, in my opinion, tangible server templates that are really cool. We've got some really great automation in these server templates, and I'll highlight a few of those things, and I'll also let Raphael show you them in the deployment that he's got running right now. First and foremost, we have an IIS server template. This is really the base of getting your application server up and running. It is an auto-scalable, compatible sort of server template. You can throw it in a server array and it will come up, based on load as the server array may be configured. And then, of course, we also have the data tier in the back, right? The database tier with the SQL Server engine running in the back. We'll cover a couple of these points later, but just to let you know, the IIS server template does connect to load balancers. There are a couple options there. The SQL Server template is currently a standalone SQL Server box. We do have a backup policy and restore failover scenario sort of worked out, and we are currently working on high availability. We are also working really heavily and spending a lot of time on automated configuration. As you may be familiar with the RightScale platform, we have some really great tools on the Linux side, and as we look at the Windows side, we found that really, and as I'm sure any Windows developer can attest to, it's not seamless to transition anything from Linux world to Windows. And so we've actually made some great strides to address some of the specific pain points that Windows developers and Windows system administrators have to deal with. And then again, RightLink 5.7, we constantly are working on RightLink. We constantly are enhancing it, trying to add additional functionality so that the RightScale management platform and RightLink can communicate better and perform even a more diverse set of functionality. Some of the things that are applicable here, many bug fixes. If you guys have used Windows in the past, you may have found RightLink to be slightly unreliable. We're working very hard to make sure that that is no longer the case. In fact, we found 5.7 to be quite stable. We have mirroring support. We do have, and this sort of talks a little bit more to the automated configuration as well, which we'll cover in a moment. But we have orderly EBS volume attachment. I'll talk about that in a second, and also the ability to do clean reboots, and I'll talk about that in a sec as well. So in terms of automated configuration, what does this really mean, right? I mentioned earlier we have a scalable IIS server template, and we have a standalone SQL Server template. So what does that? What sort of automated configuration can we really be talking about? Let's talk about that. First of all, in terms of best practice configuration, we talked about before in terms of the images that are available on the cloud. They're unsecure. They do not follow best practices. We've tried to go to configure the right images so that they do conform to best practices, so that they do have some amount of security in place. For example, on Rackspace, we enable the Windows firewall by default and close all ports because there is no such thing as security groups. So we do configure network security and isolation in a best practice manner. Pre-configuring monitoring and alerts, all of our server templates are baking monitors and alerts into the system itself so that you can get accurate information, perform actions as necessary. And you're also welcome to customize and build your own monitors as well. We have some performance enhancements in terms of faster boot times. Some of this is very detailed, but we don't reboot as often as you would expect in a typical Amazon AMI when the server is launching, which increases boot times or decreases boot times, enhancing performance. Reliable volume management, we guarantee that a volume will attach as specified to a specific drive letter before the server is even launched. Today, when a server is launched and you request an EBS volume to be mounted, you can specify the drive letter you want that to be mounted on, and Amazon will guarantee that that will occur properly. What RightScale will take is a step further. Before the server is even launched, you can request what drive letter you want that EBS volume to be attached to, and we will go ahead and guarantee that that will happen. And this enables that your applications or your database engines can know in advance where to reference certain files from as EBS volumes are mounted onto the systems. And then perhaps some of the most cool functionality, in my opinion, which is where we spent a lot of our time perfecting, is the ability to snapshot. In previous file systems and in other operating systems, it's maybe perhaps more seamless to do this or easier to do this, but with Microsoft Volume Shadow Services, it's a little challenging because you actually have to tell SQL Server to quiesce or not write to the data file so that you can snapshot and get a sane, clean snapshot that's not dirty that you can actually restore from. And we've perfected that. It's a reliable and fast backup mechanism that you can then rely on in case you ever need to restore. It's pretty cool.